List of some standard. What I've compiled here is a list of some standard functions. Many of you have seen this before. This is the constant function. Many times you see this usually looks like, for example, remember f of x means y, like y is equal to 2. You notice it doesn't say y equals 2x, doesn't have a independent variable. If it's just y equals to a constant function, it's always going to give you a horizontal line. And by the way, if x is equal to a constant function, it will give you a vertical line. Well, you're going to learn later that's called a vertical asymptote, which has a slope that's undefined. But nevertheless, this right here, many of you have seen this before. It looks like a line. It has a slope because it's sloping like a ski slope. When it has a slope, they call it identity function. We call it a linear graph, or a linear function, if you will. So many of you see these as a linear. For example, y is equal to 2x plus 3. If you recall from the last chapter, that's actually a linear equation. This function, the absolute value function, if you notice, y is always equal to the absolute value of x. So this looks like y equals, for example, the absolute value of a negative 3. Whatever x is. If you notice, this never goes below the below the x-axis. Remember, this is x and this is y. But this never goes below the x-axis because, look, isn't y equal to the absolute value of a negative 3? If you recall, absolute value functions gets rid of negatives. It's only concerned about the magnitude of a function, not its direction. You'll learn that later. But it doesn't go beyond below the x-axis because the absolute value of any negative is always going to be positive. This is a popular function that you see a lot. Many of you know this as a quadratic function. In fact, it looks like a bowl, and some of you have heard the expression parabola. Parabola. So the shape of this is called a parabola, but this is a function. The irony is it has a square value. If I was to shift this x and y, this x and y plane, if I moved it up, you would see that this x-axis would hit twice, maybe here and here. Remember from the last chapter, the exponent tells you how many times it will cross the x-axis. And just to review something, if I move this up, it would only cross the x-axis once. Look at this exponent. The square root function, the square root of a number, y equals the square root of 25 or whatever, always has this shape appearing up in the first quadrant. And the cubic function. The cubic function, because there's a cube, you should realize it should hit the x-axis 3 times. We call them intercepts. But the cubic function is kind of neat. It almost looks like a snake in some regard. It may be hit here, here, and then here. And so therefore we call that a cubic function. Okay? These are what graphs look like. However, our discussion today is not necessarily what they look like, but what happens if they shift back and forth. Where would you find information about this? Many times in electronics, they deal with the shifting of a function. For example, a cosine or sine can shift based on types of interference, constructive or destructive interference, or what we call phase shifts, where certain aspects in electronics, voltages and things like that, will cause the actual graph to deviate from its original position. So this section right here is about shifting a function. And in this chapter, we call them transformations. Just to give you an idea or a quick view about what I mean, something is going to be happening to this function that's going to allow it to shift downward from its original position or shift upward. So you know what I mean by shift. This right here may shift up, like that, or it may shift down. You're also going to learn that sometimes things shift to the right or to the left. So this blue line could actually shift to the right or to the left. Let's see the shift here. You tell me, is this a vertical shift or a horizontal shift? If I was to take it and move it from here to there, you probably would say that that is some sort of horizontal shift. So that's what I mean by transformation or transforming a function. The quadratic function can shift left, right, or up or down. And so you can see that shift up or down, that's probably called a vertical shift. Similarly, each one of these will deviate from their original position based on what I add to these functions. For example, vertical shifts, to get something to move up or down, we're going to learn that in this case, the x squared uses when you add, I'm going to use a different color here. When you add a constant to a function and it's not in parentheses, you can see this thing moves up. If this was a negative, then you probably realize from its original f of x, it would move down like that. And so that's what we're going to explore today is how do you determine which way it shifts and what are the laws that cause it to shift. They're pretty simple, easy techniques to understand once you get the idea of what these shifts are. So for that reason, let's go on and look at how we can get functions to shift.